Okay, in this volume problem, we're given a triangular prism that happens to be an equilateral triangular prism. Okay, so we have bases that are equilateral triangles. And we know that it is, the side lengths are 10 and the height of the prism is 12. And it's filled 80% with water. Okay, so what we can do is first calculate the amount or the volume of water that is in that triangular prism. Okay, and then we're going to add 40 units to it and see if to see what the new height of the water is. Okay, how much higher is the water now than it was? So let's start by drawing our equilateral triangular prism. So it has an equilateral triangle as the base, okay, and then it goes up to another equilateral triangle. This will be a very fancy fish tank, maybe 12 units, who knows. So the side lengths are 10, 10 here, 10 here, 10 there, and the height is 12. Okay, so remember, this is an equilateral triangle, so all the sides are the same. So the volume here, it's filled up 80% with water. So let's make this 80% here. So all this is water down in there. Okay, so how much water is in there now? So we want to first find 80% of 12. So we do 12 times 0.8 in your calculator. And if we do 12 times 0.8, we find that the current height of the water is 9.6 units. So since volume is area of the base times the height for all prisms, and even though it has a triangle base, it is still a prism, that means the area formula becomes base squared times the square root of 3 divided by 4 times the height. Okay, now we find this special formula here by using special right triangles. So if all of these sides are 10 and 10 and 10, that means we can draw the height here. Okay, and the height of an equilateral triangle bisects the base. So these are both 5 and 5. Okay, and there's 60 here and that's 30 there. So we have a special 30, 60, 90 triangle where the height is always the side times the square root of 3. So 1/2 of the height times the base will give us this formula right there. Okay, so anyway, continuing on. That's neither here nor there. So the base is going to be 10. So 10 squared times the square root of 3 over 4 times the height, which is 9.6. Okay, so we put all this in our calculator. 100 times the square root of 3 times 9.6 divided all by 4 means we have a current volume of 415.692 cubic units. So that's the amount of water that's in there. Now I add the rock, which is 40, to get 455. Whoops. What crazy math is that? 455.692. Okay, now that's the new volume. But the only thing that has changed about this problem is the height. So the base is still the same. The only thing that's new is a height. Okay, and this is a second height that we don't know. The water goes up, the height goes up, so we have to calculate the new height. Okay, the base area stays the same. The triangle stays the triangle. Nothing about it changes. Okay, so I'm going to calculate this real fast. 10 squared times the square root of 3 divided by 4 means this thing has a base area of 43.301. Okay, is the base area. and that needs to equal 455.692. So if I divide both sides by this base area, .692 divided by 43.301, I have a new height of 10.52 units. Okay, is the new height. So if I look, the original height was 12, so this thing has not overflowed yet. Okay, but the original water was 9.6, so it's almost gone up a whole entire new unit from what it was before. Okay, so we calculate the volume of water, we add the volume of the rock, and then we calculate the new height by just changing the h in your formula from before.